Hello everyone, today we're looking at Unit 4, Lesson 6. So further practice with a factored vertex and standard form of a quadratic. So we've learned all three forms at this point. We're going to look at basically how we work with them in terms of coming up with an equation or converting from one form to another. So this first part of our notes today, we're looking at a graph and we have to figure out what is the equation of the quadratic relation in factored form and then in vertex form as well. So you have to think about what do we need for factored form. So let's just recall what factored form looks like. Our factored form is y equals a and then x minus s and x minus t, right? So we know that s and t, those are our zeros. So we're going to need to identify our zeros from the graph. And then we haven't really talked too much about how do we calculate or how do we figure out what a is by looking at the graph. So that's something that we're going to have to solve for algebraically. But we also know that we could pull some point from the graph and plug that in for x and y. So those are the things we should identify by looking at our graph and then use algebra to figure out what a is. So let's write some steps for this. So let's say step 1, we're going to sub in zeros and a point. Okay, so if we look at our graph, we have our zeros here. So those are our zeros. So we can represent those with s and t. So let's see, one of my zeros is at -3, and my other zero is at +5. Okay, and then we can also figure out a point that's on the graph. So if we look, we have our vertex, we also have our y-intercept. Let's just use our vertex. Okay, we'll say that this is a point on the graph. Okay, and it is at 1, -16. Okay, so we have x is equal to 1 at that point and y is equal to -16. So we're going to sub all these values into our factored form of our equation. So in for y is going to be a -16. We don't know what a is. We'll leave a for now. And then in place of x will be 1. And we will minus from that our first zero, which is -3. And then we'll have 1 in the next bracket. And we will subtract from that our other zero of 5. Okay, so once we've subbed in, let's write a new step. So step 2 is we are going to find a algebraically. Okay, so we're going to use that equation we just came up with and we're going to start simplifying it to basically isolate a. So 1 minus a -3 is really 1 plus 3, which will be 4. And then 1 minus 5 is -4. So 4 times -4 is -16. We would divide both sides by -16 and we would find that a is equal to 1. Okay, so now that we have a, our last step is going to be to write our equation. So let's just make a note. We are going to now write the equation with a, s, and our t. So we can say, therefore, the equation is y equals, and we'll stick the 1 in there just to show it, but remember whenever we have a as 1 we don't need to, and then we're going to sub in our s, which is a -3, so minus a -3 is really going to be +3, and then x minus my other 0, which is 5. Okay, if we wanted to do the same thing, we wanted to write it in vertex form, generally the process would be the same, where we're going to sub in this case, our vertex. So let's first write what the vertex form looks like once again. So a times x minus h squared plus k. Okay, so generally we'd have to sub in our vertex and some point because in vertex form we're looking for our vertex. But in this case, we've already been given our a value, so we don't have to work through finding that. So let's just first of all identify that this is our vertex. Okay, and then y and x would also represent a point on the graph. Okay, and we could sub that information in to find a, but we already know a. We found a up here, so a is going to be the same no matter what. A is equal to 1, and our vertex is also that point we use. So this is a point on the graph, but this was also our vertex over here. So our vertex is at 1 and negative 16. So we've already gotten our information to basically write our equation. That would be our step 3. So we need to write the equation with a, h, and k. So in this case, we can say, therefore, the equation is y equals, and again, I'm just going to write my 1 there to show a, and then x minus my h value, which is 1, squared, and then our k value is minus 16. Okay, now we're going to take a look at how do we essentially go between the different forms of a quadratic based on how we've learned to do this so far. There's some strategies like completing the square that, like I said in the last unit, we will look at in the future. We won't worry about for this specific unit. It's already a lot of information for this new relation called quadratics. So right now in the first example, we have an equation. And we should hopefully start to be able to recognize what form this is in. So this is factored form. And we have an arrow here showing us to convert it to vertex form. So let's write down what vertex form looks like so we start getting familiar, right? So vertex form is that a x minus h squared plus k. And then it wants us to, from there, convert it to standard form, which is that ax squared plus bx plus c. Okay, so to go from factored form to vertex form, we need to find the vertex. Okay, so to go from here to here, we're going to have to find the vertex. And we know how to do that once we have our zeros, right? We find the midpoint of our x for our axis of symmetry, and then we use that to sub in to find the y of our vertex. So let's work through that. So we're going to first identify our zeros. Okay, so our zeros are going to be at x plus 4 equals 0, so x equals negative 4, and x minus 2 equals 0, so x equals 2. So we have our x's, or our zeros. From there, we're going to find the x value, or the axis of symmetry. That's the xv. So the x value of our vertex is going to equal negative 4 plus 2 divided by 2. So negative 4 plus 2 is a negative 2 divided by 2 is a negative 1. Okay, from there we're going to have to find the y value of our vertex. So we sub in to find y. Okay, so the y value of our vertex, we're going to take that negative 1 and we're going to plug it in for x. So we have negative 1 plus 4, and we have negative 1 minus 2. So if we simplify our brackets, we should have 3 and negative 3. And then we have a negative times 3 times a negative 3. So the y value of our vertex is going to be a negative 9. So we should take those two values, put them together to represent our vertex. So we have the x value of our vertex and the y value of our vertex. So we could say our vertex is negative 1 and 9. And we could also identify, because we'll need it for each form, what's our a value? So our a value here, if we look, is at the front of our brackets. So our a value is negative 1. So we're going to take this information and we're just going to write it in vertex form. So in vertex form, we need our a, our h, and our k, right? So my a value is a negative 1. My h value is minus 1, so it's going to become a plus 1 inside of our bracket. And then our k value is a plus 9. So we have it in vertex form now. So I'm just going to, so we can see that's our vertex form. Okay. If we want to get it to standard form, then we need to expand and simplify. So in order to go to standard form, we're going to expand and simplify. So we can either expand and simplify our factored form or our vertex form. We'll just start with our factored form because we're sure that that one is correct. So our factored form was x plus 4 times x minus 2. So I'm going to start by distributing this negative in so I can get rid of that. Okay, so we'll end up with y equals negative x minus 4 times x minus 2. Then from there I'm going to FOIL. So first, outside, inside. Last, we're going to get a negative x squared, and then a negative x times a negative 2 is a positive 2x. And then we'll have negative 4x and plus 8. And then from there we will combine our like terms. So 2x minus 4x is negative 2x plus 8. So that's going to be our standard form of our equation. Okay, so you can see, I'm just going to circle this one in red. We have our factored form. Okay, we have our vertex form and we have our standard form. And you can see that they should represent or look similar to the general equation we've learned for all three of those. Let's take a look at what it's going to look like if we start in vertex form and try going to standard and factored form. Okay, so some things I want to point out right off the hop, because like I said, it's always going to be the same. Let's identify what's our a value. So our a equals 2. So that's going to be the same for all of them, right? A is going to be 2 for our standard form. A is going to be 2 for our factored form. A equals 2. A equals 2. No matter what, we know A equals 2. We don't need to go back and try to figure that out. Okay, so if we're going from vertex form into standard form, let's write our standard form up above again so we can remember what that looks like. We're trying to get it into this ax squared plus bx plus c. And when we're trying to go to factored form, we want a and then x minus s and x minus t. That's what we're trying to get it to look like. So we'll start right here with our vertex form. And if we're trying to get it into standard form, we're going to need to expand and simplify. So we are going to expand and simplify. So that means I'm going to write my bracket as 2 sets of brackets. And then we'll work to simplify. So I'm going to start by distributing my 2 into that first bracket. So I have 2x minus 6. And then from there, I'm going to FOIL. So when I FOIL, I should get 2x squared minus 6x plus 18. And then we'll have that minus 8 there. This is an example we've already worked with in a previous note as well, if it looks familiar. So when we simplify, we should get 2x squared minus 12x plus 10. So I'm just going to come up here and we're going to write that that's going to be our standard form. So therefore, the equation is y equals 2x squared minus 12x plus 10. So now we've got it in standard form. Okay, if we want to get it into factored form, we're going to need to factor it. We'll say let's factor. And we always want to remember we're going to common factor if possible first. So if possible, we want to always try to common factor first. So we should see we can pull out a 2. So if I pull out a 2, I'm left with x squared minus 6x plus 5. And I see now I have a simple trinomial. Okay, so we'll set up our SPF. We're going to look for two numbers that add to a negative 6, multiply to a positive 5. So the only factors of 5 are 5 and 1. If they have to add to a negative but multiply to a positive, we should be thinking the sign on both of them is negative. So we will have y equals 2, x minus 5, and x minus 1. And you can see that we are now in factored form. And as you look at the three different forms, something just to take note of, which I had mentioned before we got started, is that our a value will be the same for all of them. So my a value in factored form was 2, in standard form it was 2, and in vertex form where we started, it was 2. So let's just make that point. Note, same a value for all three forms. Okay, one more page for today. So this next part says we're going to determine the x-intercepts for the following curve. The problem is that we've only learned how to determine our x-intercepts, which we also call our zeros, from being in factored form. So we're going to need zeros from factored form. Okay, if we need them from factored form, then we're going to have to convert from vertex form to factored form to find those zeros. So the only way to get from vertex form to the factored form right now is that we're going to have to first expand and simplify, and then once we have it in standard form, we can get it into factored form. So let's write a couple notes on this. So number one, we're going to expand and simplify. To standard form. Okay, so let's start with that. We're going to write our brackets as two sets of brackets, and then we're going to have to FOIL them to continue expanding. So we're going to have x squared plus 3x plus 3x plus 9. So if we combine our like terms, we should have x squared plus 6x plus 5. So now that we've done that, we're in standard form, we're going to have to factor to find our zeros. So we have a simple trinomial. So we just have a simple trinomial we're dealing with. So we should be able to use SPF. All right, so we need two numbers that add to our middle term, multiply to our last term. Again, there's only two factors of 5, so we're looking at 5 and 1. So when we factor this, we should have x plus 5, x plus 1. We need to identify our zeros, that's why we got it in factored form. So we'll set both of our brackets equal to 0. And we should find that our zeros are at -5 and -1. So we'll say therefore, because remember the x-intercepts are the same thing as our zeros. The x-intercepts, and I'll put zeros in brackets, are -5, -1. Okay, this last example that we're going to try to find our x-intercepts on, we're going to approach it a little bit differently. So instead of expanding and simplifying, we remember that when we're trying to find our x-intercepts, we know that our y is equal to 0. So this time we're going to set y equal to 0 and solve for x. The reason I like to show you both ways of doing this is because sometimes people aren't comfortable working with those square root signs when we get to our algebra. So if we set 0 in for our y, and then we just work to isolate x, I want to take you through what's going to happen here, making sure that we're moving things algebraically correctly. So the first thing I'm going to do is I'm going to move that 18 over by subtracting it. Okay, and then I'm going to divide both sides by 2. So I'll divide this side by -2 and this side by -2. So we should get 9 equals x minus 4 squared. Now the next thing we have to get rid of is that square root. Okay, so we have to make sure we're going to square root both sides. Okay, when I square root x minus 4 squared, we get x minus 4. But when I take the square root of 9, I get plus or minus 3. Okay, so just something to take note of here. When you square root a number, the result is both negative and positive version of that number. Okay, because what I mean by that is if you were to take 3, if I was to take a positive 3 and square it, because remember squaring something is the opposite of square rooting it, equals a positive 9. If I was to take a negative 3 and square it, it also equals a positive 9. So it makes sense when I square root something, right, then I have to take into account that that number could have been a positive or a negative 3 that got me to that 9. All right, so once you get that, you're essentially now working with 2 different equations that you're isolating. We're working with x minus 4 equals positive 3, and x minus 4 equals negative 3. So then we have to solve for both of those because we'll have 2 different solutions, which should make sense because generally we're going to have 2 different zeros. So we'll add 4 to both sides here. We'll get x equals 7. And we'll add 4 to this side and we'll get x equals 1. So this is another way we can go about actually finding our zeros. So we can say, therefore, the x-intercepts, or zeros, are 7 and 1. So you can use either strategy that I just showed you. You can expand and simplify it and then factor it to find your zeros, or you can just set y equal to 0 and then isolate x. But you have to be comfortable working with that square root part of the algebra. That's it for your note for today.